Good morning, sixth graders. This is an introduction video to talk to you about our lab today about inertia. Okay, so our essential question is, how does the amount of mass of a body in motion affect its tendency to remain in motion? In other words, how does mass affect inertia? And we have already answered that question, but this lab is meant to provide evidence for that. Okay, so write your hypothesis based on what we have learned about mass and inertia right here on this line. Okay, so that should say something about, you can make an if-then statement. If an object has more mass, then its inertia will be blank, whatever it is that you think. Okay, yesterday we made a meter stick and we fixed strings on the end. It says here with rubber bands, but that kind of creates a bump at the end. So we used masking tape to make it nice and smooth so there's no friction. Okay, so your meter stick should look something like this. Okay, it's got strings all the way down it. And we are going to position that so that the 100 centimeter mark is at the end of it. Okay, so that's going to be propped up on the blocks or whatever it is that you're propping up your ramp. And it can, all of our ramps will be kind of a different, at a different angle depending upon how high you make your ramp. Okay, so then it says put the cup at the end of the meter stick. So you're lining up the little window of the cup right with the 0 mark on your meter stick. And it says put a marble at the top of the meter stick and let it roll down the ramp and into the cup. Use a second meter stick or a ruler to measure how far the cup moved and record your data. Okay, so down here on the data table, first you're going to use 1 marble. You're releasing it from the top of the meter stick. You're going to do 1, 2, 3, 4, 5 trials, and then we're going to take the average. Remember, the average is adding all 5 of these trials together and then dividing by the number of trials. So you're going to take the sum of these 5 trials and divide it by 5 to get your average. Okay, then you're going to do the same thing for 2 marbles. Okay, so you're adding to the mass now. Take 5 trials, average, and then 3. All right, I'm going to make this bigger so you can kind of see how this is all going to go. I'm going to put my computer way over here so you can see. All right, so I got my cup. It's got a little window in it, and I am arranging that window so that it lines up right at the 0 mark on my meter stick. I'm going to take 1 marble. I'm going to release it at the top of the ramp, roll down. It's going to move the cup a little bit. Move the cup a little bit. See how it moved the cup a little bit? So we are going to then, in centimeters, we are going to measure from the 0 mark of the meter stick to the front window of the cup. Okay, so in this case, it moved 17 centimeters. All right, we do it again. Again, you line up the window of the cup with the 0 mark. Okay, I'm going to roll it down again. Okay, and then I'm going to measure again, and that one moved 18 centimeters. Okay, you're going to do that 5 times, add them all up, and then take the average, and then you're going to do the same thing, but with 2 marbles. Okay, so we line them up at the same time, release them at the same time, and the cup will move, and we measure again. Okay. Once you've got all of your data, we can then go down to our data analysis. It says make a bar graph to compare the average distance the cup moved. Remember to plot the independent variable on the x-axis. That's going this way. Okay, so the independent variable, the one thing that changes in this lab is the amount of mass. Okay, so you're going to be plotting 3 different numbers. Down here you'll have a bar graph for 1 marble, the average for 1 marble. Down here you'll have the average for 2 marbles, and then down here on your bar graph you'll have the average for 3 marbles. Now, depending upon how far your marbles went, this is going to be distance that the cup moved, okay? So you might not be able to go up by 1 centimeter, right? Because my first one moved 17 centimeters. So that would be, my bar graph would already be up here. And when I'm dropping my 3 marbles, that is going to be a bigger bar graph. So you may have to go up by 5s maybe, 5, 10, 15, 20. You might have to go up by 2s. It's whatever makes sense with your data set that's going to stretch out your data as much as possible, but still contain it within this little graph, okay? Then we've got some conclusion questions here that you can finish at the end. Alrighty. Have fun with this. We've got the whole hour today to complete this, or at least get the data set. We can finish it up tomorrow if you need a little bit more time. If you're a distance learner, and you don't have a meter stick, a yardstick will work, or any kind of a board will work. Putting the string on it, like this, absolutely helps. So even if you've got a really thick board and you put string on it, if you put it thin enough, it'll still act as a guardrail for this marble, okay? So you don't have to use a meter stick, and you don't even have to use a marble. Any kind of sphere that will roll freely on the board will work. And then a styrofoam cup, or even a plastic cup, or something that has a little hole for the marble to roll into, and then a measuring device to measure it. And if you don't have a metric measuring device, standard will work. So you can use like a measuring tape and do it in inches if you'd like. I hope it goes well. Let me know if you have any questions, and we'll talk soon.